Determine the sum of all possible products of the first n natural numbers taken 2 by 2. Let us begin. Let's try to understand the problem first. Let's say we have the n natural numbers, first n natural numbers. What we have to find out is the product of the first n natural numbers taken 2 by 2. That means we'll take the product between 1 and 2. Then we'll add it up to 1 multiplied with 3. Add it to 1 times 4, and this is going to go all the way up to 1 times n. Next, what we'll do, we'll take 2. 2 is going to now get multiplied with 3, because we have to take 2 by 2, because 2 times 1 and 1 times 2 means exactly the same thing. So if we consider 2, we're going to multiply with 3. Add it to 2 times 4. Then add it to 2 times 5, going all the way up to 2 times n. Then again, we'll take 3, multiply it with 4, add it to 3 times 5, and this is going to keep on continuing. And I hope you're getting an idea what the problem means when it says the product of the first n natural numbers taken 2 by 2 at a time. So this is what we need to find. We need to find out this sum. However, we're going to approach this problem in a different way. So let's think about this. So let's say if we have two terms a and b, we have their sum. If we square these two terms, then what will this? If we square the sum of these two terms, we're going to get a squared plus b squared plus 2 times ab. So here we observed that we have 2ab, and ab simply is the product of the two terms that are present in a plus b. Now let's say we increase the number of terms to 3, a plus b plus c, and then we square it. So now we have this sum of 3 terms, and squaring that value gives us a squared plus b squared plus c squared, added to 2 times ab plus 2 times bc plus 2 times ca. So here we can see that when we take the square of the sum of 3 terms, we're getting 3 terms here, which gives us the product between any 2 terms taken at a time. So we have a times b, b times c, and a times c. It is actually exhausting all the products between any 2 terms taken at a time. So we can extend this idea to general terms. So let's say now instead of using a, b, and c, we extend it to x1 plus x2 plus x3 all the way up to xn. So let's say we take n numbers, because these are all natural numbers, and we're going to square this value. So when we square this value, what will we get? We will get x1 squared added to x2 squared plus x3 squared, and this is going to go all the way up to xn squared. Right? This is fine. And then we'll also have the product between any 2 terms at a time. So we can have 2 times x1 times x2. We'll take 2 as the common factor. Added to, we'll have x1 times x3 going all the way up to x1 times xn. Then we'll have added to x2 times x3. Then we have x2 times x4 going all the way up to x2 times xn. And then we will get some more terms here. So what we'll do, we will generalize this. Now if we write it in a compact form, then x1 plus x2 all the way up to xn, the sum can be expressed as summation x of I, where I is an index running from 1 to n, and we're going to square this value. This is going to be equals to, now we have x1 squared plus x2 squared all the way up to xn squared. Now this is simply going to be the summation of xi squared, where I goes from 1 to n, added to 2 times. Now here we have the product of 2 terms. What we can do, we can rewrite it as, let's say we take one summation where we have x of I, and I runs from 1 to n. Then to it we are going to multiply x of j, where j runs from 1 to n, and while taking the summation, we have to make sure that I not equals to j. Meaning, when we took the product here, we can observe here that we never took x1 multiplied to x1. That means we never took the product of a term with itself. This was not done. Similarly, we didn't have x2 times x2 or xn times xn. This is what we mean when the index are not equal. That means we will never take the term and multiply with itself. Okay, fine. Now what we will do, our goal is to find this product taken 2 by 2 at a time. Then we are going to divide both sides with 1. So we have I, j, and here always make sure that I is not equals to j. and running both of them running to n, I is not equals to j, xi times xj. This is going to be equals to 1/2 of summation of x of I with I going from 1 to n. We have to square this minus half multiplied to summation xi squared with I going from 1 to n. Right. Now let's try to find out this particular sum. We'll first begin by evaluating summation of xi. Let's try to understand what is summation of xi. So summation of xi, this is simply x1 plus x2 all the way up to xn, because we have considered I, the index I running from 1 to n. But we can also think of it like this. If we replace x1 with simply the number 1, x2 with number 2, then we go all the way up to the last term, which is simply going to be n. So this is the sum of the first n natural numbers, or in other words, we can say we can replace the summation x of I with summation k, where k goes from 1 to n, and it will mean exactly the same thing. Now that means we can replace the summation half times summation of k, where k runs from 1 to n, and we're going to square this value, minus half times. Now we have summation of xi squared. And using the same logic, we can say this is going to be summation of k squared, where k goes from 1 to n. Okay, now we have a standard formula for each of the two summation. So summation of k, that's the sum of the first n natural numbers. That's going to be given by n multiplied to n plus 1 whole divided by 2. We square this value, minus we have half multiplied to, this is going to be summation of the sum of the squares of the first n terms, or first n natural numbers. So that's given by n multiplied to n plus 1 times 2n plus 1 whole divided by 6. Now we simplify this. We're going to get n squared multiplied to n plus 1 whole squared divided by 8, minus n times n plus 1 multiplied to 2n plus 1 divided by 12. Now we can combine each of the two terms. That's a very simple task which I am leaving as an exercise for you to try out. This is going to give us n times n plus 1 multiplied to n minus 1 times 3n plus 2 whole divided by 24. So this is the summation with I going from 1 to n, summation j going from 1 to n, I not equals to j, xi xj. So this is going to give us the sum of the possible products of the first n natural numbers taken 2 by